Hello and welcome. This is Fredrik from Tektronix, going to give you a tour around the RSA306 and some features and benefits which is included for free. So the RSA306 is a USB powered and driven real-time spectrum analyzer or real-time signal analyzer. There are some limitations with the hardware design, so we were not able to consume more than 3.9 watts of power in this case, and it actually reflects in our datasheet. So it's much better than what the datasheet says. Let's go for presets. So I'm going to give you two real examples. We go to VLAN band, and I put the ref level down to -30. I will go up here and enable trace 2, which is a max hold or peak hold. So this is what people are used to do today. They're slowly building a waveform, saying this is the worst instance, and this is how the signal looks like. We have, and I will go through this now, there's a general signal viewing. All of these are included for free with RSA306. The analog modulation is included for free. The difference here is you can set the individual bandwidth of these ones. And the RF measurement is for free. And spurious use, occupied bandwidth, and signal strength. This is the most common one used. Then we have another additional, this costs extra money. It's a general purpose digital demodulation, so we can demodulate almost any kind of standard. We have OFDM, audio, Bluetooth, LTE, P25, which is the US Tetra, radar. I will not talk about the tracking, and the VLAN. You can do a lot of kind of compliance or pre-compliance testing with this to check if the constellation is good or phase error is good or summer is good. So, okay. Oh, I should have chosen the DPX. So DPX, for those who don't know, DPX is a way that we do an FFT. Instead of putting it into memory, put it into a kind of a pixel matrix. And behind each pixel there is a counter, a timer, and a resetter. I mean, that's basically it. And this gives you the opportunity to do really real time and have a feeling of real time. And I can control some of them. I can control how, if 10 hits is going to be really red, and if we're going to reset after 1 second of 50 seconds. So I will just add here, the same thing. So we have a max hold, and I will clear this one and clear this one, and just let it run for a couple of seconds. So first of all, you see that you can actually see what's going on this side. Here you kind of lost a little bit. It's much slower, and this gives you not only what's happening now, but it can also give you insight of signals under signals, for example. In this case we have, I can clear this again, and I can clear this again. And you can see, which one tells you the most. So this is what we call the discover part. Discover what's hidden in the RF. And when you see this, then you can start discussing about triggering, etc. So I will close this window, and I will focus a little bit how you can tweak the DPX and what other things you can do to get a more feeling for what kind of signals you see. So I close this one, I right click here, and I just move this one in the middle. I'm gonna remove the max hold, and I'm just also going to remove the trace. So I just work with the bitmap. So here's the bitmap, and here you can see one of the spurs, by the way. So this is VLAN live. We have this sig frequency, and I press this wheel and here I can do some settings. So the first setting I can do is telling the counter, how often should it refresh itself. So let's put it to 10 seconds instead. So after 10 seconds, if the signal's been present 10 seconds, it will slowly fade away. Second thing is how do we color code? 1000 hits should be red or 50 hits should be red, and I can do auto color, and we have a max and min %, and we can also change the curve. And this gives you a little bit more insight of the signal. Second thing we can do is listen to the signal. Some people think I'm crazy, but that's actually a good way to have a feeling what kind of signal we're running. So I just run the demodulator. And you can hear it. So you can feel it is a bursty signal, and there's a way to see this visually also. If you go for a split, on the top I will have a kind of waterfall diagram, and I will go down in time a little bit. And this one is controlled. The settings here are controlled at the amplitude scale. So I go here and I just put this up a little bit, and then I put the max down a little bit. So here we can see, you can make it even a little bit shorter. And if I want to measure the distance between the bursts here, I just press stop. I go and add marker. And I have one marker here, and I put it over here. And I put another marker, add marker, and put a marker over here. And there is a delta readout here, like 100 milliseconds. And if I want to see that I'm really getting it, I can go and down here, remove the bitmap, and only show the O-gram line, which is on now. So this is M1, here's the burst, and this is the MR. So here's right, it's 100.8 milliseconds between these bursts. So let's go enable the bitmap again and just run this. So this is how you can do it. There's another thing here which is, I like, and it's kind of hidden. It's when you go in for density and show measurements, you get the kind of this bar, and this bar can tells you the occupation, how much of the signal is present all of the time. So in this case, it's kind of CV, but in this bar, I haven't, it's not completely covered, but in this case, there's a signal present 65% of what's in that square box. I probably can tweak it a little bit better. I'm not sure I can do that, like this, yeah. But if I move this one over here and just get a feeling, I can see that the signal is present 1.3, 1.4% of the time. And in our bigger brother, the bigger RSAs, we can use this as trigger conditions. So we can not only trigger on amplitude and frequency, we can also trigger on things that change over time. We call it trigger on this. So what is this useful for? So let's say you work on IoT things and you have some open bands at 868. Let's take a look what the difference would be for you. So instead here we put 860 megahertz. We set the ref level down a little bit, more than 40. We enable trace 2 with max hold. I go in here, I press the DPX. I go for the DPX, I said enable trace 2, so max hold. I go to a split. Like this, and I'm going to tweak this a little bit. This. Probably a little bit faster, it's okay. And then we have the amplitude scale. And that would be, but we're going to reduce the bandwidth a little bit to 100. Somebody's trying to call me. Like this. And we clear this one, and we clear this one, and you can start seeing, what is the difference between these two. Here you can, you can really lively see that there's something going on here. The level is not that high, but there's something going on. While in this case, it hasn't even spotted what's going on. So if I can go to 3D, and get a picture of it. And of course, the max here, we should really go down a little bit so we can like this, so it gets a bit nicer. So these are the things you can use for your IoT device to see that, is something transmitting, is there something here, and you're more likely to see it. And as you saw, I can really change the resolution bandwidth of this one, even in the DPX. In this case, we have two pulses over here that's some kind of transmitter. This is very basically what you can do. So if you close this one, you think it's it's not worth, and you run this again, and if you feel that you have some data, you can put this in 3D if you like, and you can stop here whenever you want and just replay. You can start doing measurements here also if you like to do that. So in the case, what is this pulse? You go here and add marker, and you move in here, and you have your pulse here, and you have your pulse here. And you can add here, add marker the peak. Oh, where did it go? Add marker here. Anyway, so here you are, and there you go, and it's probably around 868, which is the open band. So this last thing I wanted to tell you is that you can save this easily and you can recall. So if you go to File and Save As, you save this in a file name, you put it as acquisition data with setup. Or in this case, I'm going to recall a file, which is kind of nice. A strange VLAN with disturbance. And I will recall it and replay it and do some simple measurements. So we have data and setup. and I can put it at 3D, and I can just replay this one. And of course I need to enable OGRAM line like this. So in this case, we can see there's a VLAN burst, but my VLAN went down all the time and I couldn't understand what's going on. I recorded this when this happened, and I found out it's the neighbor's microwave oven that disturbs my VLAN burst here. This is the channel I'm using. I hope you find this interesting, and I might do a part 2 when we look at the demodulation and how you can use this as a full VLAN test.